Hey, what's happening, people? Okay, here we go. I am here to talk to you about SDA, Software Defined Access. So, this is a 6-part series, this being part 1. Why I'm doing this? Well, honestly, my lab is in dismay. It needs fixing, updating. I need to rebuild it all anyway. And I figured if I'm doing it, I could do some captures and show you guys and girls and whoever else is out there what's going on, so that we'll talk through the steps of building our fabric and getting things up and running. Each of these sections I'll kind of do a recap of the previous, what we did last week or the last video, because weeks may pass between these. We'll have a look at what's coming up and then on with the main show. So this is number 1 in the series, so we'll set the stage with the lab, we'll talk over the lab, what we have, what's already configured. I will add some timestamps into the description so you can just jump around as you see and you don't have to listen to me waffle on. And if you like this video, please go ahead and hit like, because it gives me that feedback that you guys like it and I can go ahead and make some more. And if you love it, leave me a comment and I'd love to hear from you. Your feedback, any questions you've got, and we can talk that out in the comments below. And if you want to see more, subscribe, and then you'll get notifications of the video. The usual, I think that's the usual spiel you hear on every YouTube video these days. It's like, please remember to like and subscribe to my channel. I've made a nice new deck from my previous videos, which have been around more around automation and plug and play with DNAC. As we're into a different topic, I thought some new slides would help. And as we are DNAC and DNA, they're kind of medical, they're kind of close friends, close terms. We've gone for like a medical theme. So let's jump on with the show, shall we? So what is going on? So first of all, building the SDA fabric. That's what we're going to be doing in this series. Today's video, part 1, is LAN automation, and then following on from this series so you know what's in store, then we'll go and look at policy, how we build out the policy, then we'll go ahead and configure our fabric, ready to onboard our devices, then we'll look at the border handoff element and how that works, and then we'll focus on some wireless, how the wireless integrates with the fabric, and then of course troubleshooting. Personal favorite of mine. I'm looking forward to getting to that one. We'll do some packet walks, we'll explore the user journey, so how they onboard, how everything works right through from authentication, authorization, getting onto the network, getting assigned an SGT, a VLAN, and then following the packet through the network and how we can validate that as it goes. So that's going to be an interesting one, but that's video 6, so that's probably maybe 6-7 weeks out from now, depending how much time I have. And then looking forwards, of course, videos 7, 8, 9, 10. I plan to do some on extended nodes, multi-site, some CMX application policy. No particular order, just as we get to them, and if there's any demand for ones, then I can just cover those off. There is some assumed knowledge, what SDA is. It's identity-based policy and segmentation. I mean, you can read. I'm not going to just read off the screen. There's some understanding of what it is. How to do the base build for DNAC, that's not covered here. I'll put the link in the description, but there's the link there to how to build DNAC. ICE, how ICE is integrated with DNAC. You need ERS turned on, you need a plus license, PX grid enabled. That's already been done. I did another video on that. Again, I'll link that video now. It should pop up in the left. And finally, just some understanding of these protocols, BGP, ISIS, Lisp, VXLAN, and Cisco TrustSec. Conceptually, what they are, what they do. We'll walk through the process as we go. So the lab itself, what are we working with here? So what we've got is, this is the lab we're going to be using. We've got DNAC 1336 is the version, and then this is our fabric, which consists of two 9500s and two 9300s, and then our little assistant dog. My wife wants to get a new dog. I say a new dog, we never had a dog, we've always had cats. She wants a dog, and that's the dog she's chosen. It's a cockapoo. It's instant toddler in the house. I don't know if I can handle having a dog, but I thought I'd show it up and see what you guys think. What do you think? Should we get the dog? It's going to be something, right? It's quite cute, but they grow into big poop machines, right? I don't know. But he's our little mascot for the video. So let me just go back a few. So let's just talk through this lab just so you're all familiar. So what we've got for our Fusion device here, this is a Nexus 3K. There already is some configuration. In particular, these are trunk ports going down to our access layer. This link here is going to be dedicated for layer 2 border handoff. This is a layer 2 border, or will be a layer 2 border when we configure it. So these will be our layer 3 links that hand off from the borders to the Fusion. DNAC is connected directly into the Fusion. and that's all up and running today. We have ICE as well, which is connected. It's a virtual ICE. It's connected in through some compute space into here, and that all has connectivity. So that connectivity is all in place. On the Fusion, BGP is already pre-configured to pair with the border nodes when we do the baseline configuration on them. Everything here in the fabric is been wiped, and there's no configuration on it at all. So what we're going to do is we're going to put baseline configuration onto these two border devices here. That will consist of just some IP address and reachability information so that they can talk to DNAC and DNAC can talk to them, and then we'll discover those devices and use them to do LAN automation of the rest of the fabric. Once we get to that point, then that's kind of our job done for the day. Any elements that we need to do in DNAC will also cover off, creating an IP pool, what those IP pools need to look like, and then how we assign those to the LAN automation. Okay, so let's just dive into the lab then. Okay, here we go. We have the lab. So I'm going to keep this thing over here because we got a reference point, because there's nothing worse than people rabbiting on and you have no idea where you are. So we can draw on this as we go. We got the Fusion at the top there. So just a quick have a look around. ICE is pre-built already. If we have a look in through some of the work centers, we'll see that there's not much in there. In particular, we just want have a look at the network devices. We can see there's a couple of devices in there already, the DNAC itself, and a couple of devices that are already part of the controller. If we jump onto DNAC, we can go and have a look through. We've got some hierarchy already. We're planning to build the UK GPK site. We also have a transit site and an innovation center, which we can use later on as we go through the series. And then some of the network settings. Some of them are pre-done. Some of them aren't defined. For example, DHCP is not there, so the elements we need to configure for this to be stood up are missing. I have already integrated ICE. And that's all up and running. You can see another video on how to do that. It's just assumed knowledge. So if we go to the inventory, we already have a few devices. We've got the fabric in a box site, which we'll look at later on down the line. We've got our transit control plane. This is our Fusion. It's actually an unsupported Nexus 3K. Doesn't mean we can't still get some information from it. And then this is our layer 3 bridge, actually. So that's a NAT router I've got that's connecting out to the internet, so we can do client connectivity tests. Now, if I jump onto some of the devices, just to orienteer us, this is now the Fusion, the Nexus 3K here. And all we have is VLAN 999, which is configured with an IP address. We're not actually going to use OSPF, but we've got IP address, which will be carried over this trunk link here and here, so that we can form a pairing with the remote side, with the fabric. And if we look at the BGP configuration, ROU, Nexus. I always get lost on Nexus because the config, the CLI, the config's a little bit different. It's for the corporate VRF, and we can see that we've got peering or neighbor statements set up and ready to go, so we know what the AS is going to be on those remote sites. So the other 4 devices we have, we've got border 1, which is this left one here, which has just been started up. We got border 2, edge 1 and edge 2, so they've just been wiped. They are brand new out of the box. So let's start with border 1. So all we need to do here, ladies and gentlemen, is we need to give the border sufficient configuration so that DNAC can reach it and manage it. I have a sample config here because it saves copious amounts of typing. So enable IP routing, depends on where you're from. And we're going to give it a local username password, which we then say down here we're going to use that to log in. It needs to be able to manage it via SNMP, so we can ping it. Can we SNMP access the device, and can we SSH or telnet onto the device? So they're the criteria we need to meet. Then this is the peer link between the two borders. I'm going to give that a point-to-point link, rooted, and then we'll configure. Oh, it's got a weird thing. It's picked up. The loopback IP address, because we'd like to manage the boxes from a fixed loopback. And then finally we'll configure the SVI which connects to the Fusion on this trunk port, and then configure up BGP to pair with the Fusion, and then we'll redistribute the ISIS routes into BGP. This net ID, so this is quite common when you do LAN automation. You'll see the net ID actually looks like this, and then this portion here is derived from the loopback 0 IP address. So if you're going to do the baseline configuration and ISIS as well, then make sure you meet that criteria to save DNAC overriding the configuration you apply when it goes ahead and does LAN automation. Of course, you don't have to do ISIS. The reason I am, it just makes it easier for me because I know what's happening. And then, of course, I didn't mention the Fusion is set to configured to advertise a default route down to the fabric, so that should all work. So I'm just going to go copy that onto this guy, baseline configuration for that switch. And then also I've got the border node 2. I'm just pulling that off of my other screen, which you can't see. Just trust me, it's there. Copy, 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 copy. It's pretty much the same. It's got a different last octet for the loopback. It's got a different last octet for the VLAN, and then it's got a different net ID here. Otherwise, I just picked up this weird artifact. Look, that's like a weird ASCII character. Is that the male symbol? I don't know. Anyway, we don't want that. I forget which one's the man and which one's the woman symbol. Yes, no. Oh, whoops. Oh man. I didn't mean to press yes. Ah. Can I break out of this? Yeah. That was lucky. Oh, that could have been painful. And then I'll paste that on. Paranoid, copy, and paste. Alright, so a good check we want to do now is just, I always work from the end. Can we ping DNAC? If we can ping DNAC, then we're probably good to proceed. I can't remember the IP of DNAC here. Let's just go and have a look. ifconfig. That's grep for, I know it's 192.168 something. That's this one. Of course, when we ping, we want to source from our loopback. Ah, yes. Oh, beautiful. And then from here, good. So we have a route. Let's have a look. So we can see we have a route. It's via 254 out of 101. Oh, that's interesting. This guy is going this way to get to DNAC, not this way as I would expect. Has even got a pair. So he has a pairing. Let's just have a look at the routing table here. That's definitely right, 254, yeah. That's an interesting one. So what's happening is the DNAC subnet, let's say X, is being advertised via BGP down to the border, and then we're redistributing that back into ISIS, and then on him, this guy, this border here, he's got a choice of a BGP route and an ISIS route. But he should choose the BGP route, because the BGP route is it's eBGP. Not a summary. Let's have a look at the routes. And it's the 6 route, isn't it? 192.168.6, yeah, 6. 64.254 from ourselves. I see what's going on. It's a yes, of course. So he's learnt the route via eBGP, and he's also learnt the route via ISIS, and then he's redistributing that back into BGP, and then we've got, what do we do when we locally generate a route in BGP? we give it the weight of 32768. You know, the best path BGP. Next top, is the next top reachable? Yes. What's the weight? Highest wins, and that's why we do this weight, because we want to prefer locally originated routes. You know, that's fine. We can work around that. That's not the problem for today. So we could fix that with tagging. We could filter that route out. We could. There's many ways. You know, we can have BGP advertise between the two. Whatever. However you fix that problem, it's fine. All I'm going to do in my case is I'm going to go show run for ISIS. I'm just not going to redistribute the BGP routes in, but I need them. We need them for wireless down the line. So, what would be a quick way to get this up and running? Let's just set the weight of eBGP to be higher. Fine. Route map. Yeah, let's just call it our map. eBGP. eBGP. Set weight 3273. 276. Oh, that's what it currently is. Let's make it a little bit higher. Let's just go 800. In fact, I'm going to go 4. Let's just make it so it's completely different, and then we can tell that's unusual. Do show run. I'm just going to get that route map and paste it into the other device, the other border. Yeah, a bit of a race condition we've got here. Fix BGP. So yeah, just a little design consideration there for you. Neighbor. Let's just take that there. Route map. This one. Oh, crud. Yeah, sorry, I'm being a moron. It's a separate line. In. Do show run. It's exactly the same config on both, so I can just go bosh, and hopefully that has done a reconfiguration already. Show IP BGP. Let's have a look at this subnet for Mr. DNAC or Mrs. DNAC. No. I just forced that. I haven't got soft inbound reconfiguration or anything turned on, so I can't just clear it. Let's just hard reset that session. Okay, we've got him. Weight, higher weight. Happy days. We like that, and we should learn a second. In fact, he won't be on here now because the race condition is reversed. Because now it's being learned by this guy first and advertised to him, so he will have 2 routes in his routing table. He may. It's going to clear some of this noise off of my deck. 192.168.6.0. Alright, fine. Of course, it's not reversed because BGP is preferred, and we'll redistribute. Okay, fine. Right, that's fixed. That's a quick fix. That'll do. Wasn't part of the plan, but I want to keep it in the video because it's important to be aware of some of these nuances. So that's enough. Save that config. Oh, we didn't check actually. I apologize. Show IP Ceph. Let's have a look then. Just make sure. Detail. Cool. So that is we have a route. It recurses to the fusion, and it's out of VLAN 999. So that is going the correct way, which is what we want. And let's just check the other one. This is how we ended up down this rabbit hole. Good. Fine. Save. Now we need to go and run a discovery job on DNAC and find that box. Oh! I didn't include this. There is a EM. Let me just grab that. 1 second. All right. This is cool. So just paste him on. You can do it on both of them. Fine. Why not? I didn't do CompT. No. Cool. 1. So this, basically what we've got a script saying is we're looking for a CLI pattern of a regular expression dot star. So dot means any character and star is the preceding character one or more times. So basically anything, whatever I type into the console conft, it will capture that, and the action of that will be, so we're saying sync no, skip no, so we'll run that command, the device will run that command, and then we'll produce a syslog message, which is the output of that command, which we're seeing here, captured end, captured configure terminal. And it's really cool because I can do, if I do end, if I do conf t, or conf t, that actually does, if you look at the output, it's configure terminal, it does fully expand that abbreviated command when it runs it. So it's, for information, it's interesting. Exit, end. Alright, and why I did that is so that when we do the discovery job on DNAC, we'll be able to see what the little crafty guy is passing down to the box. So let's hop on over to him. So they're not in the inventory, we're going to go and we're going to do a discovery job over here, and then in discovery, little disco job, add new, so name it, we're going to call him borders. A few ways we can do it. CDP, if we do CDP, we basically put an IP address of one device, it will go on a device, show CDP neighbors, it'll show CDP neighbors detail, and it'll find out the neighbor's IP address, and it'll try and access that device and manage that device, and so on and so forth, and it will fan out up to, however many levels deep you decide. A little risky maybe, so let's just do it based on the range, and I can't for the life of me remember what the IP is. So I do show IP in BRE, exclude unassigned, that's 254, and I believe it might be 255 as well on the other device. Yeah, 253. Let's take that IP then, and we'll go from him to him. Management, yep, so recommended, if preferred, is to use a loopback, so that's yes, we'll do as we're told. And these credentials, there are some already populated. If you didn't have any in your case, if it's a brand new out of the box, you can just add in your credentials, so you can call it, McLovin, with a username of Superbad, and a password of, secret, whatever you want to do. And then you can use that for your discovery job. But if you tick this little box here, it'll then save it into the design page as a global CLI set that you can then allocate to other sites. So it's quite useful. Same for SNMP v2. You've got read, and don't forget to do the write strings, and v3 as well. Netconf. Yes, we're going a lot with netconf and device configuration and provisioning, but it's not required for the catalyst switches. I'm going to little asterisk, imaginary asterisk there. We do need netconf enabled on them if you plan to deploy the embedded wireless LAN controller, because that's provisioned via netconf. And also, I say the catalyst switches, the catalyst 9800 is a wireless LAN controller, it's got some switching code underneath, but it's mandatory that netconf yang is enabled on that device for it to be managed by DNAC. So think wireless, think netconf for now. You might see this become more pervasive everywhere else later on down the line. So I already have some CLI configurations here. I'm just going to use those. The advanced, it's not a lot in there. Do you want to use SSH or Telnet or both? And if you want to use both, what's the protocol order you want to try them in? Cool. And then get back up there, and then run that discovery job. And I'll run it now. Thank you. And then off it goes. So 3 check. Can I ping the device? Yes, I can. Brilliant. Can I manage the device with SNMP? Yes, I can. Brilliant. Can I remote onto the device via the credentials given? Yes, I can. Then it'll go on, capture a load of information, and bring that device into a managed state. So it does discovery, and then it's passed off to the inventory app. And the inventory app then does collection on the device. So I'm just going to be quiet and fast forward this video turbo speed, because you don't want to watch this. Hey, you know what, I'm just going to, while that's doing that, I'm just going to move this over to the side here so we can see what's going on side by side. So we can see actually there's stuff happening. It's been logged on to terminal length 0, show running config brief. So DNAC's going on and it's collecting information to allow that device to be managed. The discovery page does refresh in the background. You can already see it blinking away there. Okay, so that has passed discovery. Why you're still seeing lots of information is because that's now been handed off to the inventory app, and the inventory app is collecting all this information to allow it to be managed. Lots of show commands. So tick, 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 tick. Boom. We're in. Now, what is next? I hear you ask me. So let's just go and verify that. If we go to the provisioning page, we can see that we've got those two devices are in, and this actually is the inventory app here. So that's where it keeps periodic, next every 25 minutes or 20 minutes it goes and runs a bunch of show commands to figure out the health of that box, and that's all used in conjunction with the assurance elements of the solution. So topology wise, we now have and then go green. Green is good. So these links are up, they're trunk links, and we have BGP reachability information, and these devices are managed via DNAC. So they're managed. So now we need to go and look at doing our LAN automation. So a few things for LAN automation we need, so let's do it without it. We need an IP pool. We need some address space that we can assign to the devices we LAN automate. Let's, for example, say I didn't have that. If we go on to inventory, we can go provision and LAN automation. So the primary site is going to be, so it was GPK, didn't I? Yep, GPK. The peer site is the same. There is no peer site. Primary device is going to be the UK. Okay. So there's the first problem. Any guesses? What? Yeah, you got that. You got that. Good job. So what the problem is here is we're saying, well, if we're going to use this device as a seed device, and it's part of this site, so then we're now looking, what devices do I have in that site? Well, you know what? We haven't got any. Problem. So how do we fix that? Well, we take these two devices, and they need to be assigned to a site. So actions, get away you. Actions, inventory, provision, and then we'll assign that to the site for both. And then we want to go to GPK, and UK, and GPK site. Happy days. And so what that's doing really when it's assigned to that site in our design, if we look under the network settings, we have a bunch of stuff. For example, the device credentials that we previously configured. So this was the one we used for discovery. Now if we go down to that GPK site, we can say, of those global credentials, which ones do you use to manage devices at that site? Because of course you might have different settings for different sites, and that's not just for the credentials. You may have a different DNS, DHCP, syslog, all that stuff may be different, so it gives you that kind of hierarchy. These inherit what's at the global level or the level above it as well, and then if you change the configuration here, it will cascade down, and all the subordinates below it will pick up those settings. So it's quite important that devices get assigned to the correct sites for many reasons, this being one of them. But it's recommended you go through the design workflow first and configure your NMS type elements, DHCP, DNS, and syslog. I'm going to turn this on as well, enable DNAC to be a SNMP server and a syslog server, because then we can collect the logs and correlate that information for our assurance reporting perspective. I like my banner of doom. By logging onto this device, you surrender all owned property and titles in your possession to the Fabric Administrator. That's me. Feel free to log onto my boxes, and I will gladly take shares in your house, because I need the money. So let's go and try that again. Actually, so here, if before I was on the global page, and I could see all the devices in the global level, you can go down to a site level and just look at the devices for that site. So let's go again with our LAN automation, shall we? Prior LAN automation. It's populated that site. So now we actually, if we click on here, we can't do anything. Why can't we choose this? Why can't we choose a device? Here we go. There it is. and oh yeah, it's not a peer site. We're just having a peer device, primary device, peer. It's the same. It's the same one, in fact. That one, and then the peer device. Why is that important? I hear you asking. It's important because what we're saying is any devices we discover downstream, this guy for example, off the primary device, do we also have a peer device, and does it have connectivity to this downstream device? If it does, then we'll configure this link and this link as a routed link, and configure the underlay configuration as required. If we didn't do that, if we didn't put the secondary one, then this link may not get configured, or it wouldn't get configured as a routed link. So it's important to make sure you correctly configure those elements. So the devices I discover, where do I want them to go? And to Green Park, GPK, and then what's the address pool? So here we've got a problem. We haven't got any pools defined, so we need a LAN automation pool in the design elements to allow us to do this. So let's just cancel out of that. I know we keep going in and finding problems and going back. It's important that you understand these elements, because if it just worked straight away, you'd be like, what? Where did that come from? How did that work? Why is it doing that for? And you can't ask me right now because I'm just talking to this screen. So we need some IP pools, which we have none at the moment. So let's create some. You can do this manually, one by one for each of them at the global level. We could just say LAN test, for example, and then give it a subnet 1.0, and then what is the subnet size? It's important. There's a quick check. If we put in /10 here or /8, it would fail, because it would go, well, you know, if I did an AND between the subnet and the subnet mask, it wouldn't mesh. And that's all we need at this point in time. We can hit save, and then we've got that pool defined there. Then what we would need to further do is we need to go to, so that's at a global level, that's the IP pools that will define for, not only for LAN automation, of course, it's for our VRFs, which are our VNs, our virtual networks within the fabric, so our overlay subnets. For each of those, each of the different types of pools we need for those, wired, wireless, and so on. And we'll get into that later on as we go down the line. And then we can go into here, and then we can reserve. So what we can do is we can call it, site name, X LAN Auto, AUTO, and then actually this is going to be for LAN. It's a LAN automation pool. If you click options, it does give you some help here onto what things should be used, and then what's the global pool we want to use for that, and then the LAN test, and then that's a /24. We could say, well, actually we only need a /27, so it'll take the needed address space that you define here, and then you can do this all manually. When we've got we'll cover off the rest of these as we get into the fabric creation, but it's for LAN automation, that's all we need. Now I'm not going to use that pool because, well, one, DNAC doesn't actually have reachability to that subnet, because I just made it up. I've done this a few times, and it gets a bit cumbersome. So I got lazy. So if I go back to here in my DHCP settings, which I seem to have closed down. So this is my jump box, my DHCP server. It's my everything server. In here, I already have my pools defined. But I wrote a little script. It's a bit crude, but it goes and it deletes and rewrites these as I need, based on a CSV file. And I thought, while I've got that file, I may as well use it to do some provisioning of DNAC for these pools. And that was just over here. So basically, I've got this CSV. So when you kind of push this to the Windows server, it defines, what's the name of the pool, what's the subnet, what's the first last user pool address, and then what are all my IP options. Well, actually, as I've already got these as sort of structured data, I could use this to create the pools in DNAC. And this little script just does that for us. You've got 3 options in the script. If you run it just as is, so I just run it like that, it'll go and look at that CSV file and create these pools and push them down. It's just a nice little loop it does of that file. It has other options as well, for example, and then we just verify that that's worked. We hit refresh. There's all my pools have gone in. There is a check. I can have a look at what are the pools that are already there, or I can go and just do a bulk delete of those pools. So I hit refresh, so I can see actually they're being deleted now. It's okay if you're going to be doing a lot of these build and tear down, but it's just interesting. If you want a copy of this script, by all means I can share it with you. It's, like I say, it's crude. There is probably better ways of doing it out there, but this is something to learn from, if you like. So we have our pools in now, and this is our LAN Auto pool here. This is the 192.168.65.subnet. If I go and check DNAC as well, which is not this guy, but this guy, I can see the 192, everything from 192 is reachable via this, which is actually, so that is the IP on this guy here, which connects directly to DNAC on the enterprise port. So we know that should have reachability. Should. So then we have to go and assign that pool down to the site itself. So now we can reserve some of that address space, and let's just call it GPK LAN Auto, and that is going to be a type of LAN. This is important for LAN automation, at least from all my testing. I found that if it's generic, it won't actually work. It won't come up as a valid option when you try and start LAN automation. It's just IPv4, and we want that to come from the LAN Auto pool. Oh, I made it a /25. I didn't even realize I did that. We'll just take that whole scope, and then we're not too fussed about. In here, you can put into subnets and things you like. What's the default gateway, DHCP, DNS? Again, we'll cover that later on. And I'm going to reserve that. So we can see there's 100% of IPs available here, but at the global level, if I scroll down to LAN automation, there's none because we've reserved that whole block for this one site. Now, back to where we started. LAN automation. So we go back to our site, GPK, and then we'll go actions, provision, LAN automation. And now we should see a pool. Let me delete that and re-add that back in. Sometimes these things get in a TIS-WAS. If I go GPK, there it is. Yep. So the ISIS password, I think I'm just going to go Cisco. I think the default is Cisco anyway. We are going to enable multicast. That just turns on PIM sparse mode on the interfaces. Useful to do it now, because if you don't and you later have a requirement for underlay multicast, and you then have to go manually configure it. So just it's good to turn it on. And then this is when it discovers the device, I think it's the serial number. I haven't done this for a while. It's a serial number, or it makes it's like to switch 01, switch 02, or there's some naming convention it uses. But if we type in here, GPK _, it'll then suffix that to the start of the host name. Or I can use a CSV. If I download this sample here and just open that up, you can see that how that should look. I don't want to go and get the hostname and serials off of my boxes, because I'll have to possibly break out of their startup sequence unless it's back up here still. It's not that important. There's another video I did, I think, that covers this off if you're really interested. At scale, sure, it's very important, or it's important. And then I'm going to hit not start, because I missed something actually. Select ports of the primary device. So here, what we're doing, Bluetooth. I didn't even think I had a Bluetooth device on there. Is we are selecting the ports where we're going to go and listen for plug and play on downstream devices. So that's 103 and 10.4. So we go down to here. Hey. It's pretty easy if we sort it by status. That's 3 and 4. Done. Cool. Okay, and then we'll hit stop. Let's go and jump onto that device and have a look what's happening. So basically we're going to go on, or DNAC will go on and it'll configure a DHCP pool and start handing out addresses with the option 43 to tell it to come and talk to DNAC as the plug and play server. We'll just have a look at that config. We've got, whoa. So so default originate, actually it pushed that, we already had that in place. It's configured them as access ports in VLAN 1, so these are our ports facing the downstream devices. It's configured a new DHCP pool with a network address and an option 43, which is DNAC's encoded address there, so we can talk to DNAC. Is there any configuration for ISIS? Yeah, and then it's gone into ISIS. Oh no, that's not. That is just under the loopback. That's for multicast. All right, there we are. Oh, cool. Two done. So let's go now and check. So they should have been handed to the inventory app. Let's hit return or refresh. Yeah, there they are in the inventory app. So basically, they are now managed devices. Super. That's cool. That's really good. Really good. Really good. What now? We need to go and turn our LAN automation job off. We go to LAN automation status, and then we can hit stop. So what that's going to go and do now is just go and clean up this device. It's going to remove that pool, not the pool, the DHCP pool. I was right. Yep, pool, because it's no longer needed, and clean up the rest of the configuration. So if we can log on to these boxes now, actually. So notice that I'm asked for some credentials. These are the credentials. They're still having a lot of stuff going on in the background here. So these are my two routed links up towards. So this is on this guy. So that's this link and this link configured. And then if I check out the second border, we should see now that his two links have been configured down towards those two access layer switches, or fabric edges. And if we have a look at that interface, we can see it is a /31, so we're conserving some address space there. Now, this is great for bringing up a fabric for the first time, sure. But what happens if this is your enterprise site? So you start at a proof of concept, you put in a couple of borders, a couple of fabric edges, and then you do a test. You decide that SDA is for you. You can then start taking your old legacy switches that are connected up to your existing campus network, replacing them with a supported edge, for example a Catalyst 9K. And then if you cable that to your border, or if you've got an intermediate node somewhere in the fabric, and then wherever it's connected up to, this guy for example, you'd make him the seat device and turn on LAN automation, then he can onboard that device and bring it into the fabric. Very light touch provisioning. We call it it's a DTP, but there's it's an element of LTP. We need to do a light touch to some of the elements to make it work. Cool stuff, huh? So that is done. That LAN automation job should be over. And also, so because we are integrated with our friend Mr. Identity Services Engine, if I go onto System 360, ICE is here. And before I do that, I don't really like those host names. They're upsetting me. I'm just going to rename them. I can just go conft host name. I'm just going to give it a host name similar to this guy over here. It's not back border and control plane. It's FE1, and then this will be FE2. Conft host name. No. Cool, and then just to reflect that, click here, actions, inventory, resync device. I'll just go and pull the latest config off of there. Now, I think I mentioned this, but I had to log on with a username and password here. That's because under the design setting, under our device credentials, we have these defined, SDA admin and admin, and then they are, whichever one is selected here is inherited, or is the default for the rest of the sites. If I go down to the GPK site, you can see that SDA admin has been selected as the credential. If I change that to admin, and we'd done that LAN automation job, then that would have been the credentials that would have been pushed down to that box. Same is true for SNMP and the rest of the respective settings. Now, network settings, DHCP, DNS, so those get pushed down at the point of provisioning the device. By provisioning them, we provision them with the respective network elements as well as some other elements. Now, we're missing some fundamental things here, and that is AAA. Now, when we integrate with ICE, this here, so this is an ICE server, this is the address of the PAN, and these are the addresses of our PSNs. And so if they're different, make sure you're selecting PAN on the left, PSN on the right. And then we're going to do radius for the network settings, and then for the client endpoint, actually we want AAA. Add AAA. Okay, so we want the client endpoint, AAA. No, sorry, it's ICE, and it's going to be radius for the endpoint. This is what we use. That is the PAN, and this is the PSN. And then for the network, we want to use ICE again, and we want to use TACAX. All right. Yeah, I clicked the wrong box. And then save that. And I've done that at the global level. So I can add up to 2 PSNs per site. Now, you could have a PAN with like 20 PSNs, where you've got 10 sites, each with 2 PSNs. In that case, you choose your PAN here at your global level, and then at the site, you can then choose the respective PSNs. And then, of course, if you've got more than 2, then you're going to be looking at pointing to a load balancer IP or something like that. Okay, I'm back. Well, for you guys it would be instant, but I've been gone for a while. You can see the clock's moved on quite significantly in time. Right, where were we? Okay, so we've LAN automated the 2 devices, edge. Now, the last things I want to show you is around ICE. So if I go over to here, so I'm on ICE. Yep. If we just go down to our NADs, or our network devices, we can see these are the 2 border nodes, and then we've got the 2 fabric edges. And the reason they're in there is because we've integrated with ICE as where's my settings? AAA server. So AAA, think TACAX, think network devices will get provisioned. And then if you think about radius, if you have a radius cluster and you integrate with that one, then we'll integrate with the TrustSec elements for client authentication authorization. Good. Okay, just to note, those appear after you assign a device to a site. I think I may have one. We can just demonstrate that with you. like this guy here, he is not assigned to any site at the moment, and he's not actually in ICE, so it's the layer 3 bridge 01, and you can't see him in there anywhere at all. Check this out. If I'll go actions, provision, and I'll assign him to a site, and I'll assign him to, this is the UK, I'll assign him to the UK, the transit site. Done. ICE, refresh. Oh, look at that. There he is. Beautiful. So that saves a little bit of work. And that device is in, and now we've got the radius, we've got the shared secrets, we've got the TACX and the shared secrets, and now when I go and provision that, it'll provision the device with those agreed shared secrets, and you don't have to touch the ICE configuration as much. There's still stuff you need to do if you want to do your, your AAA policies and authenticate each user command. Of course, you have to go on and do that element. Anyway, I'm rambling, I'm waffling. Let's wrap this up. Let me get my slide deck back, and I'll just pause for a second and do that. Okay, those of you that are still with us, we've reached the end into the summary. So what have we done? I've cleaned up this this lab a little bit now because the last topology was a little bit of a mess. So in summary, these are the points that were already in place for us to achieve our goals. You know, DNAC was built, ICE was already pre-built. DNAC and ICE were integrated. We'd already got PX Grid turned on, so that's some other videos you can look at if you want to figure out how to do that. And the Fusion config was set up, so we had the routing in place for reachability to the rest of the enterprise network. Although the enterprise network wasn't very big, it was just a few hops away. The Fusion had its inverse BGP configuration to pair with the fabric. It doesn't have to be BGP. I try to keep it as close to what the fabric's going to configure in regards to automation, border automation, and LAN automation when doing manual based underlays. It just saves you some headaches down the line, potentially with changes in configuration that DNAC may or may not push. So what do? We baselined the seed devices, which happen to be what will be the borders and the control plane nodes later on down the line. We just gave them the IP reachability required to talk to the Fusions and DNAC. They learned the default route from the Fusion and the route to DNAC so that these guys could communicate. Important things to go onto these devices for DNAC to discover them is going to be they need reachability DNAC, of course. They need SNMP configured, and they need some sort of access, terminal access, SSH preferred telnet if you must. Then we created LAN automation pools, so we need those IP pools to assign to the LAN automation job, because then DNASEPA can go and carve those addresses up. Sorry about the noise. I've got my kids at home. The IPs are then carved up. They're split across 3 ranges. There's the range that's reserved for the DHCP pool, which is on the seed device. There's a range that's reserved for or used for the loopback IP addresses, and then there's the ranges that are used for the point-to-point links. Remember, there's this overlapping IP address ranges you can have as well, and then you can have your transit links, the same subnets across all of your different sites. So if IP addressing is scalability is a problem for you, that might be useful. And then we ran the LAN automation and provisioned the devices. So we saw as part of that process, assigning devices to sites. They were added into ICE, which saves us elements of configuration there. You can see benefits of the whole end-to-end integration. And if you think about this at this point, you do have a very, very basic fabric up and running, but it allows us to scale. We can add in a new device here, cable it up, have this run as a seed device, another LAN automation job, and bring this guy into the fabric. So once you've built this baseline, it provides really ease of migration. So cool. Thank you for sticking with me there. How do I get rid of that pen? Unpen it. Cool. So back to the flow. Step 1 on the ladder. We're going down the ladder. So the next one to look out for is going to be policy. Remember, tune in, subscribe, like the video, comments. If you pick up anything I've said that you're not sure of, or anything that I may have made a bit of a stumble and said the wrong thing, please call me out. I'm happy to be corrected. And then we'll look at building out the fabric, the border handoff, wireless, and then some of the troubleshooting pieces. Plan to do these week by week, but work commitments, life commitments, that may not happen. But nice. hope you enjoyed, and I'll see you all very soon.